Alright guys, welcome to another Java tutorial. Today we are going to be talking about primitive types and arithmetic in the Java language, giving you the ability to store information and process all that information. Java keywords are what make programming statements happen. So if you recall from the previous lesson, we had words in there like public, static, void, and print and println. Those are all different keywords that we can only use for their intended purpose. There are other words that we can build into our programs. Those are the user-defined identifiers that are going to be the variables for what we do, and we can name those basically anything that we want. So let's get into this. Here you see in the first example that I have, and you can pull up for yourself in your own IDE, but here I've got an integer called a, an integer called b, and what I have to do is first declare them in memory. So that int says that I'm going to build them into the computer, and then I can set them equal to something like a is 10 and b is 25. And you can see down below on lines 11 and 12, I have them printing out, and you can see on the far right hand side of the screen that you print the values of 10 and 25, showing that a stored the value of 10 and b then stored the value of 25. But the trick is you first have to declare variables in Java, not like in Python where declaration is done through assignment. Here you have to first declare and tell us how much memory you want to use first before you start putting a value in there. Okay. Let's just assume you declared two variables but forgot to initialize them. You will run into an error. You can't print something that's not holding any information. So you have to be careful there. You have to make sure that you actually put some information in there. But you can take care of the declaration and the initialization step all at once. So you can declare a variable a and make it equal to 10 in one step, not like in the first example that we had where it took two separate steps to do that. Same thing with b. You can declare b as an integer and set it equal to 25 and not have to declare it, then assign it to something. So you can do them all at the same time. And this is usually the way that we go about doing it. Okay. Here you're going to see basically the same example, except now my print statement is a bit more robust. I am concatenating, if you remember what that is, where we add strings together with other pieces of information, other strings, or maybe in this case even integers. We couldn't do this very well in Python in this way, but we can do it easily in Java. It does kind of pick it up and know that we're concatenating, so we're adjoining strings. So we can print a colon and what a is, b colon and what b is, and you can see that the output in the upper right hand corner shows something a little bit more meaningful to us. So use your print statements to your advantage here. Okay. Now the different data types that you have are integer data types, I should say, are byte, short, int, and long. Okay. A byte uses exactly 1 byte of memory, 8 bits, and in 8 bits of memory you can get 256 different values. Well, that means you can use any number you want between a negative 128 and a positive 127. There are 256 numbers between those two values inclusively. Don't forget about 0. It is still a good number. A short uses 2 bytes of memory. It gives you much more. Okay, maybe some zip codes you could use for a short, but not all, not plain fields address any. They range in value from negative 32,000 and some change to a positive 32,000 and some change. An integer is 4 bytes of memory. You can get up to a negative 2 billion to a positive 2 billion, and a long gives you a lot of digits to work with. 8 bytes of memory, so those are the maximum and minimum values that you have there, and I'm not even going to attempt to pronounce what they are. Declaring them is very easy to do. Just say byte, short, int, or long, and then you can print them out appropriately. When it gets to the AP exam and what we're going to use in class, we will likely only use the integer data type. We'll probably never use byte or short. We may get into long once in a while if necessary, but the integer data type is technically the only one that is tested on the AP exam, so that's what we'll get used to using. Alright, so now that you know how to store numbers, let's talk about how to process them. Arithmetic is the way to go. We can add, subtract, multiply, and divide values. So let's say I've got a is 0, b is 25, and c is 10. I can use a as kind of the total for some different arithmetic processes. So in the first line of code in line 10, I've got a equals b plus c, and you can see the print statement actually prints out what a b plus c equals, and it says 25 plus 10 equals 35, exactly what you would expect. B minus c, 25 minus 10 should be 15, and that's what stores as a and it prints. I can multiply. We multiply with the star key, so you hold shift and press 8, and that's your multiplication. We can divide using the slash, okay? And we can use modular division using the percent sign, just like we did in Python. Now, the one difference between the divisions here in Python is that there is no such thing as a double slash here in Java. The type of division that happens, whether it be integer or real division, all depends on the types of numbers that you have around it. There is no double slash notation to force you into integer division. So you have to be mindful of what you have there. So notice 25 divided by 10 does not make it 2.5. It makes a full 2. We're trying to see exactly how many full 10s go into 25. Because we're only working with integers, we're only going to get an integer out. And that's what makes the arithmetic in Java just a little bit more complicated. You have to really focus in on what type of arithmetic you're working with. So for integer division, it's exactly how it works in Java. Something like a 12 divided by 1 is 12, 12 divided by 2 is 6, 12 divided by 3 is 4, 12 divided by 4 is 3, 12 divided by 5 is not a decimal, it is just a straight 2. Just like 12 divided by 6 and 12 divided by 7, 8, 9, 10, and 11. There are no decimals there. It's just a full 1. I can only put one of those into 12. If I start dividing it by 0, I still get that undefined result. And again, 12 divided by 13 does not come up with a decimal. It is straight 0. I can't get 13 into 12. Modular arithmetic, remainder division, a little bit different. We're trying to see what's left over. If I take 12 and divide it by 1, there are no parts left over. Same with 2, 3, 4, 6, and 12. Okay? What do you notice about all those numbers? They're all factors of 12. So anytime I divide a number by a factor of itself, I'll always get 0 as a remainder. Whereas something like 12 divided by 5, 5 doesn't go into 12 evenly, but there are 2 full parts left over because 5 times 2 makes 10, and 12 minus 10 makes the 2 that's left over. So you have to take it back kind of like it was old school division back when you were in grade school. Think about it in long division. 12 divided by 3, well, I can get 3 into 12 4 times with nothing left over. So at the bottom you see that the remainder is 0, while the full part, the integer part, is 4. 13 divided by 5, well, I can get 2 full 5s into 13, but there's 3 left over, so this would be the remainder part, so on and so forth. The zeros get complicated, because how many zeros go into 12? Well, you really can't tell, and there is nothing left over, so that's why 0 is still kind of that oddball where it will show up undefined each and every time. Now those are just integers. There's no reason we can't work with decimals, so those are our real number data types. We have a real number data type, it's called a double. Okay, double is what you're going to declare for a decimal, and that's usually what we're going to use in this class. There is another data type called a float, we'll get to in a second, but double, we call it D1, D2, or D3. They all store decimal values. Now notice in D1 I don't actually assign D1 a decimal value. It is then assumed that a decimal will come from the number. So anytime something is declared as a decimal will get assigned to it, and that decimal is accurate out to 15 decimal places. So you can see that the division sign here in the very last line of code there, where it's line 16, and the equivalent print statement in 17, where it prints 10.0 divided by 3.3 repeating, gives me a 3.000 yada 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 yada. So it does divide it out very, very nicely and evenly. But you notice that I do get a decimal response because I'm working with decimals. Anytime you're working with decimals, you will get decimal answers. A double is very accurate because it uses the same amount of memory as a long does for integer, 8 bytes of memory, so I get lots and lots of decimal places, or at least number places to work with. A float is another type of real number, but it only uses 4 bytes of memory, same sort of placeholder as an int. When it comes to the AP exam, you're going to be responsible for type double, not for type integer, okay? Excuse me. So addition of double, subtraction, multiplication, and real quotient division, they will all yield decimal answers. What about real number division? or modular division, I should say remainder division, let me say that again, it actually does work. You just get kind of odd responses. Like, how does a 1.75 become the remainder when I divide 6.75 by 2.5? Well, it is there. It's just kind of odd to think about. So we don't do it very often. We only usually use the modulus with integers, but it can be done technically. Now, even though you have these data types and some of them can get very big, if you use the wrong data type for the wrong type of number, you end up with some very odd results. So let's say I've got a program here that declares an integer here called int num and it's equal to 1,000. Well, it seems to be that I can multiply that number by just about anything. So let's take int num and multiply it by 1,000. It becomes 1,000,000. Okay, and if I multiply it by 1,000 again, it gets even bigger. And if I multiply it by 1,000 again, it gets smaller. It goes from a positive to a positive to a positive to a negative. Well, that seems kind of odd. If I multiplied a positive number by a positive number, one would think that I should get another positive. But what happens here is we actually overflow on memory. And what you can think about is kind of like a car odometer. The odometer only has so many digits to work with, so many place values to work with in your car, and it's the exact same thing in memory in the computer. If your number gets too big, it rolls over. It rolls over to the next available digit. So from 9999999 to 0. Okay? Seems kind of odd. With math in Java for us, it breaks down to binary. The very largest, let's say, byte value I can have is a 0 with, what is it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 ones. Okay, or 15 ones, I believe. Okay, when you add 1 to it, all those bits change and it overflows to being a 1 in the leading spot. Well, one would think that that would still be a positive result, but the way that Java and most computer systems deal with numbers is that the leading bit is actually a signed bit. And that's why in the previous slides we always noticed that the negative value was always 1 more in quantity or in magnitude than the biggest positive value, and that the negative value was always an even power of 2. So something to kind of keep in mind when you're working with this stuff is that when you get too big with your number, that sign bit, that very first bit, if it's ever a 1, those are all your negative values. And then as I start adding things back into this, I start getting closer and closer back down to 0. And, excuse me, and the number starts working through it. Dealing with these, it's not something we need to know how to do. We will have done some arithmetic and binary already. We will do some more as we get closer to the AP exam. But the work that we will do will be in the positive realm of numbers by adding and subtracting and multiplying those values, and we won't necessarily have to worry about that sign bit. But it is nice to know that's how it's working in the system, and so when you end up with problems and you get results that are unexpected, this is what's happening behind the scenes, and so you can make the changes that you need to make. So change something from type byte to type int, or from int to type long, or from float to type double, if you need something like that. Alright, arithmetic. Now, there's so much arithmetic that we do that we often come up with shortcuts for things. This is one of those things that Java has that Python doesn't, is the ability to add and deduct 1 from numbers very, very quickly and very, very efficiently. There are different ways of doing it. You just have to be careful in how you do it. So following this program can be quite tricky, but I want you to read each line of code starting from line 6 to 16 and also align it to all of its print statements and see what it does. First it declares num as 10 and it prints it. So here's print 1, num is 10. Then it actually does this line of code, num plus plus. What that does is it adds 1 to num and reassigns it. So num goes from 10 to 11 in line 8 and prints it, and you can see that it is currently at 11. Then I have another one, it's called a prefix. It goes plus plus num. Well, again, that does the same thing. It adds 1 to num. It does it a little differently, but it still adds 1 to num, which was 11. It is now 12, and you can see that it prints in line 3 that it equals 12. But now I start throwing those plus pluses inside the print statements, and you'll start seeing something odd. System.out.println, print line 4, num equals num plus plus. So on line 4, you notice that it still equals 12. odd. I thought the plus plus actually add 1 to num, so it should be 13. But let's look at line 5. We didn't do anything to num, and it actually printed 13. The plus plus as a postfix actually happens after that line of code executes, so it will actually print the statement first with what's currently held in num, and then after the print statement occurs, it will then change the value, which is why it didn't change for line 4, but it had changed already for line 5. Now in line 6, print 6, you're going to notice I've got num equals plus 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 num. Now that actually did change to 14. The prefix will make it change prior to the line of code executing. And you can see that in line 7 it hadn't changed again, so it actually stayed exactly where it is. Now both of them do the same thing, the plus plus num and the num plus plus, okay? And it would happen the same way if you did a minus minus. It would actually deduct 1 from k or from num, whatever you're using. But the trick of the matter is you need to find one way of doing it and stick with it. And the goal of this is also to not embed these things into other lines of code. It can get very tricky there. Just make it its own line of code where you do a k++ or a k-, or use it in the context of something else like a loop heading or a conditional statement of some kind. You just need to be careful about which one you use and how you use it. And where you put it if you are going to do some combination of statements. Now my suggestion and how I will always do it, I always like writing the postfix k++ and k-, and I will always write them as their own line of code. But essentially all they're doing is adding or deducting 1 from the value, okay? So again, how I like to use them versus the problematic usage. So try not to use the statements at the bottom there where you put them inside their own print statement. We have some other shortcuts too. Adding 1 and deducting 1 is not the only thing we can do. These statements look a little bit more like Python, where I set a value x equal to 10, and then I can increase or decrease it by any amount I want, and these are called unary operators. Not only do they do what they're supposed to do, but they make the assignment, and they do it to only one value. So I can go in x plus equals 10, and what you'll see is that increases x by 10, and so you can see online now, it prints it out, it says x equals 20. I can go x minus equals 10, it goes back to 10. X times equals 10, it becomes 100. X divide equals 10, it becomes 10. X mod equals 10, and it becomes 0 because the remainder of 10 from 10 is 0. What it does is it does the operation on x or from x upon 10 and reassigns x each time. You do need to get them in the right order. You cannot write something like x equals plus. It has to be x plus equals, x minus equals. But you can put any value you want over on that right hand side. And the plus equals part will always be the last thing to evaluate. So if you wanted to write more expression over on the right hand side with the 10, you can. It's not often the case that we do so, but it is possible to do so. So here's the non-shortcut versus the shortcut notation. I enjoy using the shortcut notation. I will use the shortcut notation in class. Most of you are going to be used to that shortcut notation from Python, so you will see it plenty of times before we start progressing too far throughout this course. Okay. Constants. Constants are values in programs that should not change. So if you declare a constant for any particular reason, you're assuming that you are basically saying this is a number I'm going to use many, many times throughout that I want to give a name to. Something like maybe an interest rate or pi. Those are constants. To declare a constant, you still declare the variable, but you include the keyword final in front of the declaration. So you'll say something like final int constant, or final double constant, 3.14159. You'll notice that in lines 9 and 10, it's throwing errors because I'm attempting to change those things, and I can't because they're declared as final. Anything declared as final can never be changed from that point forth. So you need to make sure that when you're using something as a constant, you do not plan on changing it. Those are named constants. They're used to be something that should not change throughout your program. Right? There are other data types other than numerical data types. We'll explore more of these as we progress through the course, but a character is just a single character. Notice it's not held in double quotes, it's held in single quotes, and you need to make sure of that. In Python, single quotes and double quotes are essentially the same thing. In Java, they are not. Double quotes are for strings, single quotes are for single characters. The data type is char. You proceed it with char, whatever you want to call it, and set it equal to whatever it is you want to make it equal to. In line 10, you'll notice a method called called chaining, where we set several variables equal to one thing all at the same time. It's not something we come across very often, but it can be useful if you do have a few variables that need to be made all the same thing at once. A string is a collection of characters, so like a word, what we were typing in our previous lab. So string first name, Kathy, string last name, Smith. Now what you'll notice here, different than the other data types, is that the word string does not actually come up purple because it's not a primitive simple data type. It's actually you declaring an object. And we'll talk way more about objects later on, but just notice that it is a little different. You do have to start with an uppercase S on string, and it doesn't come up purple because it's not a simple primitive data type. It's something much, much more than that. And we will study what that is a little bit later, but you can use it as if it's a simple primitive data type. The different data types all work differently. So 7, 7.0, 7 in single quotes, 7 in double quotes. If you declare them as int, doubles, char, strings, they all do things a little bit differently. So when you add ints to ints, you get int results. If you add doubles to doubles or doubles to ints, you get double results. You can work with characters and even add them up, and work with strings and even add them up, but you'll get those data types back out, either chars or strings. So even though they can all look the same in terms of their value, they're all very, very different because of their data type. Okay? I think I mentioned this word a few moments ago. Concatenation is the appending or joining of two strings. So the plus sign is technically something we call an overloaded operator. It's something that can do multiple things based upon what's around it. So for instance, I can add 2 and 3 and get 5, or if I were to wrap the 2 and 3 inside quotation marks, 2 plus 3 is no longer 5, but it is now 23 as a string. And the same example as I have here is a 100 plus 200 is not 300, it's a 100200 as a string. So me actually putting words together. Okay. The last data type we want to talk about is Boolean values. Boolean values are consist of one binary digit in memory. It's a bit. It's a 1 or a 0 because it can only take on two values, true or false. We'll use these quite a bit in the context of loops and things of that nature, but they are very, very simple to use, and they are simply set equal to the keywords of true or false, and those are the only values you can assign them. Okay. The data types that you're expected to know come AP exam are the int, double, boolean, and string data types. We will not test you on the AP exam for byte, short, long, float, or char. It's not bad to know them. It doesn't mean you can't use them in, say, your free response section, but they will definitely not be tested on the multiple choice section. Okay. The last thing we want to talk about is if we're doing all this arithmetic and changing of things, we might as well be able to get information from the keyboard, from the user. To do that, we have to create something called a scanner object. Okay, so there's just some preliminary code that you have to enter before you can start getting information from the computer. And we'll discuss this more in class as we go. But the scanner object's pretty easy to set up. The very first thing you need to do is actually import the ability to use a scanner. So this line of code you're going to make sure that you need anytime you need to use a scanner object. If you attempt to instantiate, build, declare a scanner object without doing this, Eclipse will kind of show you a warning and say, hey, would you like to import this for yourself? And you can just click it and it'll do it. But either way, the scanner object needs to be declared. You need to give it a name, and then you're going to create a new scanner object with this system.in parameter. This allows you to tell the system that you're going to be gathering input from the keyboard. There are other parameters that you can set there to get information from other places like files or audio sources or whatever it may be. Then to use it, it's actually pretty simple. Print something on the screen, some sort of prompt, and then grab information from the user using some method of the input object. So this is your first kind of opportunity to use objects. So input.nextLine, nextLine is a method that allows the console to kind of pause, the program to pause and allow you to enter something at the console, press enter, and as soon as you do, it will read whatever you entered, like Tony Stark, and store it into name, and then you can start using it in whatever way that you see fit. If you want to grab numbers, you can do that. You can just use put any information in. But you'll notice some odd results if you enter numbers and use that next line method. Okay, because remember, the next line method is going to grab information from the console as a string, and so when I add two strings together, remember we concatenate just like we did in the previous example. So how do you actually get numbers? Well, you change the method. If you want to get an integer, use input.nextInt, and that will allow you to grab integer values from the console, and then when you add them up, you will get the appropriate response. 100 plus 200 is 300. If you want decimal values, the method's pretty simple. It's input.nextDouble, right? And that'll allow you to input a double value. And once I hit that double value, I can do basically anything I want with it. Here I'm just printing them out and coming up with their average. Okay, so these are the methods that you'll need to use in order to get information from the console. Next line, next int, next double, all of those will have to be called from the scanner object that you declare. In our case, we called it input. You can technically call it anything you want, but again, we'll discuss that more in class. The last thing we need to kind of talk about here is the fact that it can be kind of difficult to get multiple data types of values from the computer. So what you need to pay attention to is when I create a scanner object is that if I have this string, a value, and the second string, some things don't work really appropriately. So notice this program does this. It's a system.out.print, enter the first string. So it says that. Let's say I type in the word first and I press enter. Well, that gets stored in a first string. Then it says system.out.print, enter a value. So it does that. It says enter a value. I type 2 and I press enter. Then it says system.out.print, enter the second string, and the word first is already printed. Well, what happened? It seemed to have completely skipped this input.nextLine, and it absolutely did. Things got kind of goofy, and then it kind of bogged out on us. When you start using the scanner object to gather input that is of different data types, the information is stored in a buffer, and the next line method doesn't necessarily always clear that buffer out, and things get kind of goofy. So my suggestion to you is, and again, we'll go over this more, is that if you're grabbing input of different types, create different scanner objects for those different types of information. Create a scanner object for strings, create another scanner object for integers for your numerical pieces, and then you'll avoid any buffer issues that we may have. But we'll talk more about that. It should never be an issue in this class because we'll either be reading in string information or numerical information, or we'll read in information from a file that is both, but it will always come in as a string no matter what, and we'll change it later to be what we need. So we shouldn't have much issue with this, but if it does come up, we'll know how to fix it. So that should kind of do it for this particular video. Odds are that was a lot of information to take in, and we are going to take our time with it going through some of these examples in class. But replay it if need be, and yeah, we'll get ready for the next lab where we will be doing some calculations on mortgage payments and things of that nature. So we'll see you.